Hello everyone. In this video I'm going to be talking through what we mean by specific heat capacity. I'm going to explain how you can use the value for a specific heat capacity to work out how much energy you transfer in a system, and then we'll talk about some of the uses of this particular value. Now imagine the scenario. We've got a pan here, got a frying pan, and into that frying pan we're going to put some oil. So we've got a little bit of oil into that frying pan there. And we're going to put that on the heat, hence this little drawing of a bit of a flame here. So we're going to heat this oil in the pan. Now I want to know exactly how much energy is required to heat that oil to be able to fry some food. And I want to know that not just because I particularly like my food, let's say, rare, but because I want to know how much energy it's going to take to do that. Now, the amount of energy that an object stores relates to its mass and the temperature, but it also relates to the nature of the material itself. And we have this thing called specific heat capacity. Now, the specific heat capacity of a material is the amount of energy that you need to be able to raise 1 kilogram of that material by 1 degree Celsius. So we'll just make a note of that. It is the amount of energy needed to raise, I'll just put temp for temperature there, to raise the temp of 1 kilogram, that's key, 1 kilogram of a material by 1 degrees Celsius. And that's what we mean by specific heat capacity. The amount of energy needed to raise the temperature of 1 kilogram of a material by 1 degree C. Now if we think of some units that this particular value would have, because that's important, because if we consider that we're looking at energy transferred, we're talking about mass, we're talking about temperature, the units of specific heat capacity are going to be joules per kilogram degrees C. Now that will make more sense when we put these together into a formula. Just to quickly say that different materials have different values for their specific heat capacity. So for example, water, let's put in blue, so water has a value of about 4,200. And if we compare that to something like aluminium, so aluminium metal, what you find is that aluminium has one that's far, far lower. Aluminium's specific heat capacity is about 880. Cooking oil, so the one I used in my example, cooking oil, the specific heat capacity of that is it's about 1,200. So you can see you've got these three different values. So let's put these into a context. Let's put a formula down. So the formula for specific heat capacity, or rather, the formula to work out the energy transferred using specific heat capacity is as follows. So we've got E, and E refers to the energy transferred. Is equal to, and we said it depends on the mass, so that would be our value for M, and that M is our mass, times by C, and C is the symbol we're going to use for specific heat capacity, and we're going to multiply that by this symbol theta, and that represents our temperature change. So we'll just put temp change there. Now again, if we need to consider the units of these, so energy transferred would be in joules. There, we've got mass, and that would be in kilograms. Specific heat capacity, we've said at the top, is joules per kilogram degrees C. And we've got the temperature measured in degrees Celsius. So there we've got a formula, E equals mc theta, that allows us to work out how much energy we transfer using a value for specific heat capacity. Now we could technically, if I just draw this in front of the theta sign, put a little triangle for delta. Now delta means change in, because we're going to consider the change in temperature that we get. So often exam questions refer to temperature changes, so they could use this particular symbol delta in front of the theta in the equation and say equals mc delta theta. Let's think of a particular example. So we've got here a kettle. Very simple. There's a kettle. We've got water being poured out of the kettle. And you're told that it contains 1.5 kilograms of water. You're told that the temperature at the start is 18 degrees C, and you want to know how much energy is needed to bring that water to the boil. So if we use our equation, E equals mc delta theta, we know that the mass is 1.5, the specific heat capacity of water we've got at the top as 4,200. The temperature change, delta theta, well, if we're starting at 18 and we're bringing it to the boil, which is 100, that's going to give us a temperature change of 82 degrees. So if we times that by 82, so we've got 1.5 times by 4,200 times by the temperature change, that gives us a value of 516,600 joules. So 516,600 joules, which if we were to simplify would be 516.6 kJ if we wanted to get that value into kilojoules. And there you go, that's very simply how you work out the energy transferred using values for specific heat capacity. Now let's think about the importance of this, why you would need to know about this and why schools teach about this. Now, we've said that specific heat capacity of material tells you how much energy it can store, but different materials are used for particular purposes because of their values. So one question they might ask is, why is water used in a central heating system? Now water, we've said, if we look at the top here, water has a very high value for specific heat capacity. So it can transfer a large amount of energy than a liquid that has a lower specific heat capacity. We've seen in this calculation, because it relies on mass times specific heat capacity times temperature change, the bigger value for C, the specific heat capacity, the bigger the energy transferred. So water can transfer a lot of energy. Now because of this, it means that we don't need to keep pumping water very, very quickly around the central heating circuit. So, in answer to the question, I said, why is water used in central heating systems? It's because, one, it transfers a lot of energy, and two, it can do that slowly. We don't have to keep pumping the water very, very quickly. There are things called electric storage heaters, and they have actual blocks of concrete or bricks, and these bricks of concrete store energy. Now, this heater uses quite cheap electricity during the night to heat the blocks and slowly releases this energy over the day. Concrete has a very low specific heat capacity compared to water, that is. And it's also a lot simpler to make and maintain this type of heater. So what's handy is that this storage heater can actually store quite a decent amount of energy because of these large blocks of concrete. And it also means that the temperature of the blocks can be lower than if less material is used. So we've got this electric storage heater with these blocks of concrete, low specific heat capacity, so they can maintain an adequate amount of energy. They release the energy much slower, and also if you use less material, the temperature of the box can be lowered, so you can use it kind of as required. And then you've got oil-filled radiators, and these also store energy, and they're designed to provide a sort of gentle, steady heat. Now oil, we can see, I said, the oil here has a specific heat capacity of 1,200. Still much higher than aluminium, but not as high as water. It's still quite high. And what it means is that we can transfer a lot of energy. A lot of energy gets stored in the oil, and then that gets radiated out and is carried by convection from the surface of the heater. So a question they might ask is, why does a storage heater need to store lots of energy? It needs to store lots of energy because it may have a lower specific heat capacity, and it's so that it can release that energy over a longer time period. So we've got these oil-filled radiators, these electric storage heaters, but also these central heating systems that rely on water. So that's why it's important to consider specific heat capacity, because knowing what the specific heat capacity of the material is allows us to essentially alter the function of the material we're using. So just to recap, it's the amount of energy needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius. And we use the formula E equals mc delta theta to work out how much energy is transferred. And you can rearrange that equation to calculate a value for C separately, or to work out a particular temperature change, for example. So that's a little bit on specific heat capacity. Hope all that helps.